So a little bit about me. I've been developing software for probably 15 years now going on. I've developed in most major languages that are used on the web. I have 2 engineering degrees, one of which is in chemical engineering and one of which is in software engineering. And it's really not about my background. I just wanted you to understand like where I'm coming from. So when I evaluate a language, I bring a certain engineering mindset to it. So as we go through this talk, kind of keep that in the back of your head. Like when he talks about this, he's coming from an engineering standpoint. I like creativity as much as the next person, but when I'm writing code, I really want to be engineering code. So that may show up here. I also am crusty and old, so I'm using note cards, and I have very baggy pants on. So I'm not like a new hipster, which is cool, but I typically don't look at languages from a new hotness standpoint. It's very much in engineering, like what can I get done with these things? So Go, has anybody seen the logo? But one of the best parts of Go is all the cool Gopher logos that they have. I tried to get a Gopher t-shirt. They do not have them. They're out of stock. I also tried to get a little Gopher stuffed animal that Rob Pike always has during his talks, but they were out of those too. So not only is the language hot, but so is all the swag that surrounds the language. Maybe someone from Google will hear this and send me a shirt and a Gopher. And I said, as my goal is to help you understand why we've chosen Go. So I'm going to start out with a little history. So as many people know, those that do not understand the past are doomed to repeat it. So I'm going to give you a little bit of history of where Go came from, how it came to be, who was involved. I'm going to explain to you at a high level some of the aspects of Go that I really like. There are many aspects of Go that are really cool, and I'm more than happy to talk to people as we go about them, either after the conference today or in the tomorrow during the open talk sessions. Show people code. We can do that, and show you a short introduction. One of which Matthew stole my thunder on, which is the Go CLI that I helped start to rewrite 3 weeks ago. And another one is the Loggergator project, which is our log aggregation product, which I helped start write too. So 2 big projects, both started in Go. I'd never written Go before I started Loggergator. Rob joked with me one day, he's like, hey, you might want to start learning Go. I was at actually a Scala conference. I was at Scala Days, and I'm tweeting how cool Scala is and sending out all these things. And I got an email from Rob saying, you might want to start looking at Go. And I was like, all right, cool. And then like 4 weeks later, he's like, hey, now you're going to start writing Go. Did you start looking at it? I'm like, no. But we'll talk about that later, too. And then, yeah, if you've got any questions as we go, let's have a discussion around that. So I just want to understand we're all starting at the same point. We are talking about writing software that runs on gigantic arrays of computers. We are not talking about brochure websites, which some people are trying to write in Go. There's actually a Rails clone in Go called Revel. I am not talking about that. I'm talking about writing high-performance, highly scalable software, the CLI being kind of a counterpoint to that, but I'll explain how that goes down later. Yeah. So a little bit of the history of Go. It was started in 2007 by some pretty heavy hitters in the industry. So how many people recognize those names? Yeah, so you got a guy that wrote the V8 engine and the hotspot compiler for Java. And you have 2 guys that worked at Bell Labs that wrote most of Linux, or a lot parts of Linux, and the Plan 9 operating system, which never saw the light of day. So 2007, so was that 6 years ago? Oh, actually, 6 years ago, almost to the day, that work began inside of Google on this project. A year later, Russ Cox, anybody know Russ Cox? Worked with a bunch of those guys at Bell Labs. Another systems programmer joins the team. So you now have 4 heavy hitters in the Unix community working on a language inside of Google. There must be there's something going on there. November 10th, 2009, they open sourced the project. So this is the big turning point for Go in my mind, is that many people bash Google for starting projects and never really supporting them all the way through. This one went open source, fully public. It is not a Google project any longer. It is an open source project given to the community. So there are many people outside of Google that are working on writing Go. The next big turning point, 2012, Go goes 1.0. So the reason this was a big turning point was that they said now you can start begin building production apps. We will make a pledge to you that we are not going to go rewrite a bunch of the APIs. So much that Rob Pike on the mailing list is always pushing back on people that want API changes. They're like, no, we're going to do backwards compatible here. You're not going to have to worry about writing a bunch of production code in Go and then 1.1 comes out and we're going to release a bunch of new things, or 2.0 is going to come out in 6 months and now you're going to have to rewrite your whole stack. They actually have not announced the timeline for Go 2.0. So they're really focusing on using the language inside of Google and making it better. In early 2013, we rewrote the router in Go. So a year after Google releases it, we're like, all right, let's try this out. So why Go? Can everybody read that? Anybody want to read that for me? No. OK, cool. Just remember that URL. So there's a URL at the bottom. It comes from the Go FAQ. I literally copied that verbatim. You don't need to read it. I'm going to highlight some big pieces of that for you. So one big piece, frustration with existing languages. So how many people do systems programming? Yeah. Do you all enjoy C and C++? You do? OK, sweet. I haven't written C++ since college. So there was a frustration within Google. They're doing, think about the software that these guys write. Gigantic, single code base. They tell stories about the build system. It's like, dear God, that stuff could put this man on the moon. So they were frustrated with that. They were being forced to choose between efficient compilation, efficient execution, or ease of programming. They couldn't get all three in the existing tools. And heaven forbid you go to a dynamically typed language. Woo, Ruby, Python. So we start writing a lot of things in Ruby and Python. Matthew talked about how we have a lot of code in Python, or not Python, Ruby. So they were being forced to choose, and the only choice they could go to was a dynamically typed language. How many people write Ruby in here? How many people want to write large, gigantic systems in Ruby? That's what I thought. I've done it. It's painful. What did they want? They wanted ease of programming. They wanted something that was easy. That's why we go to dynamic type languages. How many people went to Ruby because it was easy? Yeah. I love Ruby. I used to write Ruby full time until I started writing Go. They also wanted efficiency and safety. So what don't we get in Ruby? We don't get efficiency and we don't get safety. We have a dynamically typed language that is interpreted at runtime. Network and multi-core computing. How many people like threads in Java? Yeah, that's what I thought. And it's networked. Think of the Google infrastructure. Rob Pike tells stories in all of his talks. If you haven't watched the talks on Go, I highly recommend it. Not only is Rob Pike very entertaining, but they're really good. All these computers talking to one another. We now have multi-core computing. So this is a new thing. Many of languages weren't around. We didn't have this in many languages that were written. And they want to build a large executable on a single computer. So what did they do? They wrote a new language. So let's talk about frustration. How many people are frustrated with the languages they're writing in? So there's some frustration. We have one gentleman down here who loves C++, and that's awesome. You can still actually write C++ in Go, which is kind of nice. But remember who wrote this language. These guys that were writing, these are system programming experts. These guys are writing Unix, and they were frustrated with what they had. You look at C++, C, Java, Rust. Anybody written Rust? What do you think? Eh? How do you like Rust? Yeah? It's still new, though. It's still a relatively new language. Is anybody using Rust in production? No, OK. So they all have trade-offs. Again, we're being forced to choose. So why do I need to choose? It's 2013. I want jetpacks. I was promised jetpacks. Sometimes I feel like I'm programming like this. I have this little copter that I can get around on it, but it's 2013. Where are my jetpacks? So they didn't want to choose anymore. And as I said, we're all going to dynamic languages. So Ruby's great. I love Ruby, but Writing large systems in Ruby is really hard. Anybody have a really long-running test suite in Ruby? Yeah. The reason we have long-running test suites is because we have to build up all of this structure around our code. Anybody writing Node in production? I'm sorry. Every time someone says they put a Node service into production, I was like, oh man. JavaScript is written to script the browser. It was. It was written to script the browser. So what do we want? We want ease and safety. How many people want? How many people want to be easy to program and a type system? Any Scala developers in here? Yeah, that type system's a little heavy. Go has actually got a really nice lightweight type system. So anybody write Go in here? One. Wow, cool. All the rest of you guys that are developers have your hands up. I highly recommend like tonight, tour.golang.org. So we want something that's easy to use. So Go has a garbage collector, which is really awesome. It's a kind of old school. It's a mark and sweep garbage collector, but they're actually improving it as we go. So you have garbage collection. You have a small spec. So the Go spec, I think, printed out is 50 pages. I think it took me like 4 hours to read. So there's just not a lot going on in the language. It is not a language that someone has created as part of their PhD thesis. No disrespect to Mr. Ordersky in Scala. I mean, Scala, like lots of dark corners. There are no dark corners in Go. There's no magic in Go. So many of you metaprogramming in Ruby? Wow, no, come on, liars. Everybody does metaprogramming. There's none of that. It's just really straightforward, which is one of the reasons I love the language so much. You get pointers, but no pointer arithmetic. So I get some sort of safety. I get this mechanism, this lower level paradigm, but I'm not worried about like stepping into somebody else's memory space. And it's fast. So I don't know, Rob Pike gives a mention of whatever, compiling the Google code base, but it's really fast. So anybody do TDD in Java? What's the one thing that makes it a little weird to do TDD in Java? The JVM startup time. Like you go to run your tests and you're like, all right, sweet. Have you seen that XKCD, the compiling one where they're on chairs like sword fighting? Yeah. Go doesn't have that. We actually can get into a really nice TDD cycle with Go because it compiles so fast and it starts up and runs so fast. I talked about the lightweight type system. I love Scala, but the type system is just kind of mind-bending sometimes. Go has support for network and multi-core computing built in. So we've got, in 3 lines of code, I can stand up an HTTP server in Go. With one keyword, I can make something asynchronous. It's called a Go routine. You literally put the keyword Go in front of a function call, and I now have concurrency. I have a thing called channels in Go, which allow me to do concurrency. Has anybody read the CSP paper from Hoare? Really? Wow. Cool. That's awesome. I had this notion of channels, which it's like a telephone. I have 2 ends to it. I hand one end to my Go routine, which I think of as like a server running in my process. I keep the other end. And when I need something from the server, I call it up and say, hey, you got anything for me? And if it doesn't answer, because it doesn't have anything for me, I just sit and wait. And then when it does, it puts something on the channel and I can go about my business. And because concurrency is so cheap in Go, I can spin up thousands of Go routines. I think the Loggergator server that I'll talk about in a little bit has 20 Go routines out of the box, just kind of idling. So I'm just spinning these things up, waiting for things to happen. It's very much like event-driven programming, and that's where I get my concurrency safety. Is I only have one Go routine running at a time, and if I'm waiting on something from another Go routine, I'm blocked, waiting on that other thing to run. So built into the language, it is not a library, it is not a bolt-on, it is not third-party, it is built into the library. And that was the way they could assure that it actually worked well. Yes, question? I have no idea how it's implemented. It's not deferred nor promises. It's built into the language. It is this whole paradigm of I have these freely running processes. I think of them as like, the way they describe them is I have servers running inside of my memory space, and I have clients also running inside of my memory space. And they are simply mechanisms that when I ask for something off of a channel, if that channel does not have anything for me, I block. I just stop running. And the GoRoutine scheduler schedules other people around me. And then when something comes onto that channel, when it comes back to me and says, hey, are you ready to run? I can say, yep, I got an answer, I'm ready to go. And they eliminate this mechanism of multiple things operating on the same thing. You can still do that. You can still kind of shoot yourself in the foot with sharing memory. But the cool thing about Go is they actually have a tool built in called the race detector, which will tell me as my tests are running whether or not I have a possible race condition. So they haven't prevented me from shooting myself in the foot. They've kind of just put the safety on and told me, like, hey, don't take the safety off. Other languages kind of hand you a gun, the safety might be on or off. They don't tell you how to put the safety back on. So they've done a lot of things to make it a lot simpler for me to do concurrency, which is a huge thing right now. Like I said, the Loggergator has 20 Go routines just idling, waiting for requests. It also allows me to think, yes, sir?
Can I ask a serious question?
Sure. Am I not being serious enough for you?
C++ Go?
I believe you can. So there is a thing called CGO. I don't know a ton about it, but it is the mechanism that they use to communicate with C. So I believe you can do C++ in Go, but I'm sure they've got some documentation on that. So yeah, so you've got this whole idea of concurrency. The networking built in, like Unix sockets all built in. Again, jetpacks. Like, this is what I want as a developer. I don't want to have to think about all of this stuff. This whole blocking mentality allows me to think more linearly about my programs so I can reason about them, and that's why we get concurrency problems. Is like if I can't reason about my software in my head, and I'm getting older and I can't reason as well in my head, that's where we get into problems. This concurrency model allows me to reason a lot more clearly of what's going on in my system. And the build a large executable, like we don't have gigantic executables. I think the CLI executable when gzipped is 1.5 meg, which includes the full Go runtime. Loggergator, what's Loggergator, Alex? 1.9 meg for a Loggergator server. So relatively small, but they're fast. Like I said, I can get into a TDD cycle. Like literally have my tests running in a window and just watch them go. As soon as I save an IntelliJ, I save the files. Tests are running and tests are green again. Most of the tests run in less than like 2 milliseconds, 3 milliseconds.
So does Go have a robust testing framework?
Kind of. Does Go have a robust testing framework around it? So they have taken the very bare bones approach. There's a testing framework built in. How many people are familiar with XUnit type style testing? It's even lower level than that. Like I don't even have assertions in Go. What I do is have this testing object that I can either say yes or no, it passed or failed. There are political reasons for that, many of which are found on the mailing list. We've actually chosen to go with an assertion library. So very much, our tests look very XUnit-like. And we've been super happy with them, super happy with the testing. But it's built into the language, so it is like a first-class citizen. It's not this bolt-on. So what do they do? They wrote a new language. So I mean, you think about it, C, 1970s. C++, 1980s. Java, 1995. We haven't seen a new language. Even Ruby. I mean, Ruby was like 94, 93, 94. We haven't seen a new language come out that addresses this stuff. That's what we get. We get Go. What we don't get is a box of Legos. So this is the other thing I love about Go, is it's not a just gigantic box of Legos. Anybody had this as a kid? You get this gigantic box of Legos, like, I can build anything I want. Like 6 months later. What I get is I get a kit for assembling system software, very much like the X-Wing. I have these pieces. It shocks me every day I write code. I go to reach for something. I'm like, oh, I need a socket library. Or I need crypto. And you're like, oh, there's a standard library for that. They really sat down and said, what is the things I need to write software, systems level software? And they put it in Go. And it's been really, really impressive to see how well that's worked out. This is one of my favorite quotes from a friend of mine. Writing boring code that does exciting things is greater than writing exciting code that does boring things. I feel very much this way when I'm writing Go. The code is not exciting. It is not sexy metaprogramming. It is not a lot of hotness. A lot of error handling in Go, a lot of if error not equal to nil curly braces, but it lets me do really cool things. So a little bit of a background on what we're using it for. As I said, the first one is the logging agent. So how many people have used Heroku? Heroku logs -- tail. This is our baby. Relatively new, didn't exist in Cloud Foundry up until recently. We've gone into private beta within the company on Friday, so congratulations to the Loggergator team for getting that out and running. It's pretty exciting. Written in Go. So a couple of pieces to this. This is the business end of the Loggergator. So what we have here, as Matthew explained, we have the DEA. Inside of the DEA are these things called warden containers. It's called warden because it's like a jail. And the user apps run inside of the warden containers. And what we're doing with Loggergator is we want to aggregate your user logs, active record logs and things like that. So what Warden does is Warden writes standard error and standard out onto Unix sockets. And that is kind of the door in the jail cell, like the little door that they push the food through to the prisoners. That's how we get our log messages. We're also doing the same thing with the router, the cloud controller, the service gateway. So we want to eventually at some point with Loggergator be able to take all of the logs about your app. So not only user logs, but router logs. Like, hey, I routed this request to this instance on this DEA. All that stuff from the UAA. And what we did is we ended up using Go for this. We made it super simple. We used the Unix socket as a layer of abstraction between the outside and the inside. We were forced to do that with Warden, but we were not forced to do that with the rest of them. So what we've done is we've written like Ruby and Go things that run inside of our processes, and then this single generic agent that sits on the outside of the Unix socket and simply listens for messages and ships that off to the Loggergator. So really nice. We have one generic piece and then a bunch of customized pieces on the inside of these things. I will get to that in a second. So the question was, what are we using to get back to the aggregator? I'll get to that in a second. The biggest concern we have here, especially on a DEA, which is where client code runs, is CPU usage. So we don't want these agents sucking up a ton of cycles because the more cycles the agent sucks up, the less cycles we can sell to our clients on run.pivotal.io. Or if you're running behind your firewall, you just have to buy that much more hardware to keep the apps up and running. So we chose Go. We did some load testing. I was actually not involved in the load testing, but I heard kind of secondhand from a bunch of folks. At full capacity, we're literally sending enough log messages where Warden shuts the application down because the application is using too much memory. The DEA agent runs at 0.5% CPU usage. Like almost nothing as this thing is getting crushed with log messages. And it's not doing a whole lot. It's literally just taking a message from here and like shipping it off to the thing, but literally 0.5% CPU usage. And that was like, wow, that's pretty amazing. So the next piece came up here of how we were getting things. So this is the kind of the meat and potatoes of it. So as those messages come out of the applications and out of the pieces, they end up in this big Loggergator server. And it is simple. I think, are you guys still at UDP sockets, Alex? Still using UDP sockets? Again, just like, okay, we drop a couple, so be it. And we've actually now just begun the scaling of this thing. So when we originally wrote it, we wrote for one instance of Loggergator, we're just going to hammer this thing. We've now begun to scale it horizontally, and that work has begun. So what we've done now is we have a little router, the router hashing proxy thing that sits around the storage servers is now just a layer that is hashing. So when a message comes in, that thing gets hit. It figures out what instance of Loggergator server it needs to go to, and it ships it off. So we're doing the hashing in another little Go program. So we've got all these little pieces that we can slot together, all again using network communication, all these really low-level things, all built into Go. And then the piece you're not seeing, which is the far left side of that, is where when you connect a tail, so we'd use WebSockets for that, there's another piece that's written in Ruby in the CLI right now that uses the same thing on the other end to say, hey, I'm looking for log messages from app XYZ, which Loggergator server do I talk to? So that's how we've decided to do horizontal scaling, is we're going to pin you to one of these servers, and we're going to write these little agents that tell me where you end up and what Loggergator server you're going to do. The other piece of Loggergator, so outside of the streaming, is short-term storage of your log messages. So if you don't connect anything to Loggergator, we're just going to drop your messages on the floor. We do have a short-term window. I don't know what we're at right now as far as how long we'll hold on to them, but you can dump your logs. So I want to dump my logs, and we'll give you whatever we have. I think we're guaranteeing like the last hour. The third piece being that if you want persistent storage of your logs, you're going to connect something like Splunk to this thing. So implementing the Heroku Drain API, you could connect a service, and we'll just dump them out there forever, and you can do your log aggregation over there. What Loggergator is not is a log aggregation and analysis service. It is simply a broker for collating all the messages, holding onto them for a short period of time, and then sending them out. The really interesting thing about this is that this project, for everybody on the team, was our first shot at writing Go. None of us had written Go professionally before this. The code started out kind of messy. We started to think really object-oriented. Like we were writing Ruby and Go, which caused us a little bit of pain for a little while. The one big thing I learned with Go is that if you're writing Go, check your object-oriented brain at the door, because Go is not an object-oriented language. It has concepts of object orientation, but it is not an object-oriented language. It will only cause you pain if you do that. But in, I think, how many weeks are we at now on Loggergator, Tamer? 3 months. We have a fully functioning server already in production from a bunch of engineers that had never written Go before in our lives. So pretty quick ramp-up time. Like I said, it was a little painful at the beginning. We wrote code. It was working. We refactored a bunch. So that type system came in really handy as we were tearing the pieces apart to try and make them more idiomatic, which is awesome. You're like, sweet, the compiler's telling me that A is not plugged into B. Awesome. I plug A into B, and everything works. So that was really cool. I think that's the biggest concern that people have when you start talking Go is like, oh, it's a brand new language, and who's going to write it for you, and this, that, and the other thing. I mean, you're talking seasoned engineers, so most of us have been writing software for a long time, but we'd never seen Go before. So really easy to translate the mental model in our heads onto paper into code. Yes, sir.
Is it the plan for Foundry to move 100% to Go, or only some parts that need low level, like maybe Bosch moving to purely Go, or what's the plan on that?
So the question was, what is the plan to go full Go? I don't think, personally, I don't know. I'm not in charge of those decisions. Personally, I would like to say no. Go is a very specific language for systems level programming. So yes, things that need to be high throughput, high scalability, I don't see why we wouldn't at least try to move them towards Go. Like Matthew said, the health manager is going to Go. The CLI is really not systems programming. I'll touch on that. Why we did that, made that decision. But I would like to see us write as much Go as possible. I love the language. I love Ruby too, but for stuff like this, I don't want Java, just too heavy, like too bloaty. I do not want to be writing C++. I don't want that. I really want to write Go. I get the kind of the syntax of Ruby, and I'm more than happy if somebody wants to see the Go code, I'm more than happy to step through that with people. The syntax of Ruby, kind of the ease of use, without all of the sharp edges of C and C++. So here, open source, you can go take a look at it. As I said, I'm more than happy to step through code with people if they want to talk about it. We have 2 members from the current Loggergator team here as well. So if you want to take a look at it, you want to talk to us about it, please come find us, and we will chat through that with you. The second piece, as Matthew said, is the CLI. So that's a lot of words. pretty much Matthew stole my thunder. Our big pain point was distribution. So as a Java developer, as a Python developer, as a developer that was not anything, doesn't write Ruby, why do I need a Ruby installation on my machine? Ruby Gems is hard. If I'm running Windows, like that's crazy town just to begin with. It is. I mean, trust me, we had a large client whose name will remain nameless. We showed up with Ruby Gems and was not an option. We literally had to go back and like figure out how to compile. We actually went to JRuby, compiled a WAR file, and used Java to run our Ruby process on Windows. It was kind of a big black eye for us. Yeah, it was bad news. And Windows is not well supported in the Ruby community. It just isn't. So we decided to go to Go. There it is, up and running. So right now we're calling it GoDash CF. That is running code. We've been going for 3 weeks on this. And James, how are we doing?
Awesome.
Yeah, so James says we're doing awesome. We have most of the functionality for managing application lifecycle. So we can push an app, we can log in, we can target, we can push an app, we can now set services. Friday we finished up listing stacks. So it's good. It's coming along really well. Again, 3 weeks. We're just flying through this stuff. We are not the first ones to do this. So anybody know packerio? They were actually the first one. Mitchell has been very adamant about never writing a Ruby gem again. It's just not worth it. If you're distributing software, it's just not worth it anymore. Again, I don't want Legos. I want the Star Destroyer. This is what I want to hand our clients. I want to hand them one statically compiled binary that they can simply upload. So another, for systems programming, I'll use sysadmins. How much easier it is to upload one static binary and then just bounce the process versus trying to like get this like crazy bundler thing to work. So there's been some great talk in the community about this. Jared's in the room somewhere, yeah? I think I saw him. I only recognize him from Twitter pictures. Dr. Nick had a great write-up. He thanked us for doing this. It's just great. It's like, here's a binary. The other great thing about Go is I can cross-compile to 3 operating systems on my Mac. I can compile OS X, I can compile Linux, and I can compile Windows, all with one script. If you go into the repo and you go into bin/build all, that's how we build all 3 binaries, right on our Mac. So it's kind of nice. It's kind of good. We also have another success story. We have a new developer who started with us this week. He has never written Go before in his life. He and I worked on a feature. He's here in San Francisco, and we miss a 2-hour overlap at the end of the day. I left him with a half-finished story on Friday when I left at 5 Boulder time. By 6 o'clock San Francisco time, he had finished the feature and pushed it up to GitHub without my help. So he was able to pick up enough in 3 days of Go programming, 3.5 days of Go programming, to finish up the feature without me. So another testament to the ease of use of Go. There's the repo. There are my credits for all my Lego pictures and my jetpack pictures. Do you have any questions? How much time do I have? Okay, cool. I don't have any more time, but please come find me if you have any questions. We can chat. We can look at code. Yeah. Thank you very much.